Good day, everyone. I'm Teacher Marian Milianes, and you are welcome in my class. Sit back, listen, watch and learn as I explain the lesson for today. The second topic in Mathematics 10 is all about illustrating arithmetic sequence. Here, the goals you need to achieve is to illustrate an arithmetic sequence. But what is an arithmetic sequence? The next slides are real-life situations showing arithmetic sequence. Quarterly grades in mathematics, prepared freshly baked donuts, and monthly savings. Let us examine the examples in order to define arithmetic sequence. First example is the quarterly grades in mathematics. In this card, it is shown that in the first quarter, the grade is 88. In the second quarter, 84. In the third quarter, 80. And in the fourth quarter, 76. How will you describe the terms in the given sequence of the quarterly grades? What is the conjecture? Every quarter, the grades decrease by 4 constantly. From 88, when you subtract it by 4, the answer is 84. 84 minus 4 equals 80. 80 minus 4 is 76. The terms generated in this example are 88, 84, 80, and 76. Second example is the prepared freshly baked donuts. On the first plate, there are 3 donuts. On the second preparation, there are 6 donuts. And in the third preparation, there are 9 donuts. What happened to the number of donuts from the first preparation up to the last preparation? The conjecture is that donuts are prepared by adding 3 constantly. In the first preparation, we have only 3 donuts. After adding 3 donuts again, we have 6 donuts in the second preparation. And in the third preparation, 6 plus 3 equals 9 donuts. Then the terms in the sequence are 3, 6, and 9. The last example is the monthly savings. In the given table, it is shown that in January, the savings is 25 pesos. In February, 50 pesos. March, 75 pesos. April, 100 pesos. And May, 125 pesos. The conjecture here is that the savings constantly increase by 25 pesos. From an initial saving of 25 pesos, added by another 25 pesos, that is equal to 50 pesos. 50 pesos plus 25 pesos equals 75 pesos. 75 plus 25 equals 100 pesos. 100 plus 25 equals 125 pesos. That's why the generated terms in this sequence are 25, 50, 75, 100, and 125. With the 3 given examples, how will you now define the arithmetic sequence? What is the condition in order for you to say that a sequence is arithmetic? An arithmetic sequence is a sequence where every term after the first is obtained by adding or subtracting a constant number called the common difference D. We have already discussed in the topic generating patterns that if you add or subtract a constant number from one term to another, use the general term a sub n equals a sub 1 plus n minus 1 times d, where n is the number of terms, a sub 1 is the first term, d is the constant number you add or subtract from one term to another. D is a positive integer if from one term to another you add a constant number, and it is a negative integer if you subtract a constant number. A sub n equals a sub 1 plus n minus 1 times d is the general term for any arithmetic sequence. But how did we derive it? Let's have this activity entitled Derive Me. The problem is, Ezra decided to save money. In his coin purse, he has an initial saving of 25 pesos. He plans to add 15 pesos a day. Make a table to show the savings of Ezra for 5 days. The first row shows the number of days in which Ezra will save money, and in the second row, the savings of Ezra per day. Completing the table, the initial saving is 25 pesos. The added saving per day is 15 pesos. In day 1, the savings is 25 pesos. In day 2, 25 plus 15 is 40. In day 3, 40 plus 15 equals 55. In day 4, 55 plus 15 equals 70. And in day 5, 70 plus 15 equals 85 pesos. On the 5th day, Ezra has a savings of 85 pesos. Let us now show the solution in order for us to derive the general term of any arithmetic sequence. In the first day, the initial saving is 25 pesos. On the second day, we added 15 pesos. 25 pesos plus 15 pesos equals 40 pesos. On the third day, we add another 15 pesos. So 25 pesos plus 15 pesos plus 15 pesos equals 55 pesos. On the fourth day, we add another 15 pesos. So we have 25 plus 15 pesos plus 15 plus 15 equals 70 pesos. On the fifth day, we have 25 plus 15 plus 15 plus 15 plus 15 equals 85 pesos. Let us now show the solution in shortcut way. Let a sub n be the nth day and a sub 1 be the first term. A sub 1 is equals to a sub 1 plus 0 times 15, since we do not add 15 pesos yet on the initial saving. A sub 2 equals a sub 1 plus 1 times 15, since we add 15 pesos on the second day. A sub 3 is equals to a sub 1 plus 2 times 15. A sub 4 equals a sub 1 plus 3 times 15. And finally, a sub 5 equals a sub 1 plus 4 times 15. What do you notice with the relationship of the multiplier and the subscript n used? Yes, the multiplier is equals to n minus 1. Therefore, the general formula for any arithmetic sequence is a sub n equals a sub 1 plus n minus 1 times t. To summarize, for any arithmetic sequence, number 1, consecutive terms are generated by adding or subtracting a constant number called the common difference. Number 2, the general formula for all arithmetic sequences is a sub n equals a sub 1 plus n minus 1 times d, wherein your d is a positive number when you add a constant number from one term to another. And on the other hand, d is a negative number if you subtract a constant number from one term to another. To apply the concepts of arithmetic sequence, let's have these exercises. Practice 1. In physics, displacement is the minimum distance between the starting and final positions. In finding the displacement of objects, we use d sub n equals d sub f minus d sub I, where d sub n is the displacement, d sub f is the final position, and d sub I is the starting position. The question here now is, a man travels 1,250 km to north but then backtracks to south for 105 km each to pick up his 4 friends. Is the sequence of his displacement in picking his 4 friends represent an arithmetic sequence? Why? So our formula is d sub n equals d sub f minus d sub I. For d sub 1, from his starting point of 1,250 km, he backtracks by 105 km. So that is 1,250 km minus 105 km equals 1,145 km. For d sub 2, 1,145 km minus 105 km equals 1,040 km. For d sub 3, 1,040 km minus 105 km equals 935 km. D sub 4 equals 935 km minus 105 km equals 830 km. Remember, terms of an arithmetic sequence are generated by constantly adding or subtracting a constant number called common difference d. The problem represents an arithmetic sequence. When the man backtracks, the displacement constantly decreases by 105 kilometers. Therefore, d equals negative 105 because we subtract the constant number from one term to another. Practice 2. Look at the following sequence. Which of them are considered arithmetic sequence? If it is an arithmetic sequence, give the value of the common difference d. Number 1. 3, 6, 12, 24, and so on. Is this an arithmetic sequence? No, this is not an arithmetic sequence because here we multiply 2 from one term to another. 3 times 2 equals 6. 6 times 2 equals 12. 12 times 2 equals 24. Remember, when we say arithmetic sequence, we are adding or subtracting a constant number from one term to another. Number 2. 5, 8, 11, 14, and so on. This is an arithmetic sequence. Why? We add 3 from one term to another. Remember, when we add a constant number from one term to another, that is one condition in order for you to say that a sequence is an arithmetic sequence. D equals 3. Number 3. 29, 18, 7, negative 4, negative 15, and so on. This is an arithmetic sequence because from one term to another, we subtract 11. Since we subtract 11 from one term to another, then our common difference is negative. D equals negative 11. Number 4. 0, 2, 6, 12, 20, and so on. Is this an arithmetic sequence? This is not an arithmetic sequence. If we get the difference from one term to another, 2 minus 0 is 2, 6 minus 2 is 4, 12 minus 6 is 6, and 20 minus 12 is 8. So the first difference is 2, 4, 6, 8. Therefore, you didn't add a constant number, but multiples of 2.